So we are going to do another interesting problem from this exercise based on Cardans method. Let's see. Sir, this is very, very simple, sir. Sir, there is already no x square term and we can straight away apply the Cardans technique. Okay, this is going to be fun. Watch. Let x is equal to u plus v, cube both the sides, take all the RHS terms to the LHS, and now you need to just compare. What comparison? Sir, this negative 3uv is going to be equal to negative 3, and at the same time this minus of u cube plus v cube is going to be equal to positive 1. Let me start the comparison. uv is equal to 1 and u cube plus v cube is equal to negative 1. Done. Cube both the sides. So u cube is root 1 and v cube is root 2. This is the product of the roots and this qualifies as the sum of the roots. Put negative 1 over here so that this becomes positive 1. T square plus t plus 1 is equal to 0. Okay, is it possible to solve this quadratic equation, sir? We've got to use the formula. There is no other option left. Again, if you watch, for applying the formula, you need the values of a, which in this case is 1. B is also 1. C is also 1. So yeah, minus b plus minus under root of b square minus 4ac upon 2a. That's the formula which we'll be using. If you simplify this, this is what you get. Inside a root, you get a negative value. I mean, this is the first problem when we are making a quadratic equation in T and we are getting a complex root. Okay, this is something that I told you before in my first lecture. Let me just go back. There could be a case when, what if the roots are complex? In that case, you'll have to take use of the De Moivre's theorem, and that is going to be very interesting. If the roots are not complex, then the problem is already very easy. You need to calculate the value of either x or y as per the problem, and then you divide the polynomial. You again get a quadratic equation, you solve it, and the remaining two roots are found very, very easily. This is slightly different. What happens if the roots are complex? Okay, so let me demonstrate how to deal with such questions. That means u cube is equal to a positive value, and similar is the case with v cube. Okay, these are conjugate pairs. What is next, sir? U is going to be equal to, inside the bracket, okay, this term, and power is going to be 1 by 3. Let me write it this way. Agreed? Yes, sir. Split the terms, negative 1 by 2 plus iota times of root 3 by 2. Now, from here, we are going to set an environment to apply the De Moivre's theorem. Let us say that negative half is r cos theta and root 3 by 2 is r sin theta. All okay? All okay, sir. Okay. Square. So r square cos square theta will be equal to 1 by 2 and its square. Negative 1 by 2 and its square. Similarly, r square sin square theta will be equal to root 3 by 2 and its square. Take r square as common. This is going to be 1 by 4. This is 3 by 4. 0.75 and 0.25 and 0.75. This will make 1. Okay, so the value of r happens to be 1. That's all. What's next? The next thing to do is to get the value of theta. R sin theta is equal to root 3 by 2 divided by r cos theta, which is equal to negative half. This is what you get. And the result is tan theta is equal to negative root 3. If you punch this value in a calculator, what you get is theta. Theta will work out as negative 60. You'll see a negative value in your calculator, right? But sir, what does this negative value indicate? Allow me to give a demonstration. Let's say that, sir, this is our coordinate axis. Okay, very well. How much value did you get, sir? Negative 60. So negative 60. So negative 60 would look something of this sort. This, by the way, is negative 60. If I can extend this to the other side. Okay. Okay. What is the angle over here? So this also has to be 60 degrees magnitude wise. I mean, whenever you calculate angles, always do with respect to the positive x axis. That is the standard. Sir, if this is 60, this has to be 30. Sir, this is 90. So this entire angle with respect to the positive x axis has to be 120 degrees, and that's why you see a 120 degree over here. One more thing, I'll be writing all the stuff in radians. Now 360 degrees is equivalent to 2 pi radians. Agreed? Proportionally? Yeah. If you divide both the sides by 3, what you have is 120 degrees is equal to 2 pi over 3, and hence let me write it, 2 pi over 3. So a very, very important concept. I'm sure a lot of you would already know this. Done, sir. So we've got the value of r and we've got the value of theta, which we are going to punch in later on in this session. What's next? Take a look. I have replaced negative half by r cos theta and root 3 by 2 by r sin theta. Okay, and this is what I get. You can plug in the value of r as 1 immediately, no problem. Let me do that. Secondly, sir, but why have you replaced this theta with theta plus 2n pi? And over here also we can see that theta has been replaced with theta plus 2n pi. Well, both cos and sine are trigonometric functions and they happen to be periodic. Okay. Allow me to discuss. Let me show this to you. Let us start with sine x. Okay. And this, by the way, is 0. This is at pi by 2. The value of sine is 1. This is at pi. The value is 0. And somewhere here at pi by 3 pi by 2, the value is negative 1. And again at 2 pi, the value is 0 again. If you watch between these two, when the angle was 0 and when the angle was 2 pi, you are getting the same value. Similarly, when the angle was pi by 2, the value of sine was 1. And when the angle was 5 pi by 2, the value of sine x was 1. That means it is repeating. Okay, after a particular interval, it is repeating. What is that interval, sir? It is 5 by pi by 2 minus pi by 2. That is 2 pi. You can also say, sir, this is going to be 2 pi minus pi. Okay, so after an interval of 2 pi, the trigonometric function repeats itself, which sin x repeats itself. Therefore, it is periodic about 2 pi. Similar is the case with cos x. If you watch here, you are getting the value of cos x as 0, as 1, by the way. Okay, at 0 radians. Again, here at 2 pi radians, you are going to get the same value. If I go ahead again at 4 pi radians, you are going to get the same value. That means it is repeating itself after every 2 pi radians. It is periodic about 2 pi. So that is the funda which I am going to be applying. And here we go. Theta plus 2n pi, where the value of n happens to be 0, 1 and 2. And basically what you need to do is you need to apply the de Moivre's theorem. Okay, we are just setting up the environment. Now take a careful look, zoom in. Cos theta plus I sin theta is equal to cos n theta plus sin n theta. That essentially means this power 1 by 3 will come inside. Theta plus 2n pi over 3, and here also theta plus 2n pi over 3. Let me do the substitution quickly. Done. We are now left with just plugging in the value of n as 0, 1 and 2. Also, we need to plug in the value of theta as 2 pi over 3, which I am going to do in the next 2 slides. Watch this. When n is equal to 0, obviously you will have a positive value, we will have a negative value. This term eliminates theta by 3. N is equal to 0, theta by 3 remains. Okay. If n is equal to 1, what remains is theta plus 2 pi over 3. When n is equal to 2, what remains? 2 is 4. Okay, these are all the values of u, these are all the values of v, corresponding to n is equal to 0, 1 and 2. But sir, what about theta? We also calculated theta to be 2 pi over 3. Put the value. If you watch theta, let me do this for you. Theta is 2 pi over 3, by the way. This is 2 pi over 3. Theta by 3. Solving just for theta by 3. Sir, 2 pi over 3 divided by 3, and this is going to give us 2 pi over 9. 2 pi over 9 at all of these 4 locations basically. Done? Yes, sir. Okay, now take a look at this much portion inside the bracket. Theta is equal to 2 pi over 3, sir, plus 2 pi. Let me put this inside a bracket and divided by 3 over here. On solving this, what you get is 2 pi. 3 into 2 is 6. 6 pi plus 2 pi is 8 pi. 8 pi over 3 divided by 3, and this will result in 8 pi over 9. Let me get out of the picture. Okay, so this is going to be 8 pi over 9. 8 pi, 8 pi. Similarly, you can have 14 pi over 9. But sir, we don't want the separate values of u and v. we know very well from our initial assumption. We started the Cardans technique believing that u is equal to, not u, but y or x is equal to u plus v. Isn't it? X is equal to u plus v. So we need to apply this ASAP. Okay. So let's do that. U plus v. Let me do that. The moment I apply this operation, the imaginary terms are going to cancel each other out, and what's left is just 2 cos 2 pi over 9, 2 cos 8 pi over 9, and 2 cos 14 pi over 9, which happens to be the 3 roots of this cubic equation. Okay, wonderful, isn't it? So I hope and I strongly believe that this problem has given you an insight into the case where the value of t turns out to be complex in nature, and then you need to apply the de Moivre's theorem, okay, to get the final roots of your given equation. So yes, students, that was all from my side. If you find this content helpful, to share and like the video with all your friends and classmates, and don't forget to subscribe the channel and also press the bell icon so that you stay updated with all my latest content. This is Manas Patnaik signing off. Take care and have a nice day.